Well, hello everyone, and welcome to this third session, third masterclass on Kubernetes. And this is a class or a series of classes where we are taking you through all the CKA, CKAD preparation missions. And at the same time, you would basically build solid skills on the topic of Kubernetes. So what we have covered so far is we spent a couple of weeks. First week, we started with containerization, where we talked about how do we get started with building container images, write Docker files, etc. The last session, the second mission we talked about was about pods. How do we use pods? What is Kubernetes? How do we get started creating pods? We looked at various aspects of pods, what are containers, what are pods, and so on. And we ended up working, managing, troubleshooting the pods last week. This week, we're going to talk about scalification, where we'll take up the topics of namespaces, replica sets, and the autoscaler. It's mainly scaling is all about replica sets and autoscaler. But before that, we'll take up the topic of namespaces plus contexts, which is quite important. And then we'll embark on the journey of from next week onwards, it would be networkization. Then we'll talk about deployments, persistent storage, security, hem, ingress, production-based grade cluster setup, administration, and finally end with Argo, Argo CD as our kind of a CD environment that we would talk about. So here we are talking about the scalification part, and let's get started with a kind of a understanding of why do we need scalification, how does it work, how do we scale applications in Kubernetes, and so on and so forth, right? Just to give you a brief about what we have covered earlier in the previous sessions, and also we are streaming this session on YouTube Live as well at the same time. For the members who are our geek members and the nerd members and the silver members, we have the Zoom channels that you can join in as well. So in case if you have questions, people from the Zoom can unmute and speak. You can put that on the chat as well. And if you have questions, if folks from the YouTube live stream, you can just paste in your question or type in your question through the chat as well, right? I will not be constantly watching the stream, but I will address the questions as and when I get a chance, and at a regular intervals, we'll pause for the questions, right? Now, what are the, I mean, these, if you cover, so just to give you a brief about for the people who are completely new, if you cover all these missions along with, let's say, as part of these master classes, we talk about the topics and you will have access to the recordings. Beyond that, if you want to have access to the courses, projects, cohorts or groups, coaching, as well as certification, you can join our membership. Specifically, the Geek membership is what you can get started with, which will give you access to all of these, and that would really give you the entire package, which will help you to master Kubernetes as well as prepare for the CKA and CKAD certifications. And all of these topics have been aligned with the CKA, CKAD topics. And I've already shared the agenda and the outline, the course kind of a curriculum, which talks about what we talk about every week and how it maps to the CKA and CKAD topics, etc. Let me just bring up that curriculum once and talk about what is it that we are taking up this week and how does it map to the Kubernetes certification curriculums as well. So this week we are taking up, this is our third mission, which is about scalification. We're talking about high availability, scalability, replica sets, horizontal pod autoscaler, etc. The lab guide is linked from here, and I'll share that with you as well. And apart from that, these are the topics we are talking about. Context are very important because when you appear for the certification exams, you are given multiple environments. Like there are 4 or 5 environments, and you have to switch between those environments. Or let's imagine you have access to 4 different clusters. Now you have to switch between those. How do you do that is by setting the context. So it is supremely important for you to understand what are contexts, what are namespaces, how do you switch between contexts as well as the namespaces, both. We will talk about the controllers, replication controller in specific. When we talk about that, labels and selectors are important. We'll talk about scaling and high availability. We'll also touch base on auto scaling with horizontal pod autoscaler, at which time we'll take up the metric server and monitoring as well. How does it map to the CKA and CKAD topics? You can see that here. So this is the foundational topic for CKAD as well. Before, if you look at deployment and stuff, this is based on replica sets as well. And for CKA, these are the topics that it maps to, right? So it basically aligns with some of the topics with CKA and CKAD. And essentially, this is one of the foundational topics anyways that you need to understand. So what are we talking about? We're talking about pod and scaling. Why we're talking about scaling the pods is because that's how you deploy your container-based workloads in Kubernetes. You don't run containers, but what you run are the pods. And those are the ones you replicate, those are the ones you scale. And right now, if you look at it from the last week, I have a set of pods here, and these pods are neither high available nor scalable. Let me show you that. If I delete those, so if I delete the pods, I'm going to delete two of these pods, vote and web, and those would just be gone. So these are not high available because nobody is watching for these pods. Nobody cares about these pods and its availability yet because we are not running these pods via any sort of controllers. Once they are gone, they're gone. Okay. And there is another pod though, which is this visualizer that you see on the right, that has been launched via controller. So if I delete that, let's find out what happens as well. So I've just deleted these two pods and those are gone. Nobody watches, nobody comes, it's not coming back. But if you look at this kubeops view, which has been running for about 4+ days, so 4 days, 23 hours, if I delete this pod, observe what happens. So when I delete this pod, this application will be unavailable for a brief amount of time, and then it will just come back up. That's what you see. So that pod is gone, but it has been replaced with another one. Okay. It's gone for now for a brief amount of time until it comes back up with a new pod, which should be in a running state by now. Just launched it 27 seconds ago. How did this happen and why did it not happen with the other pods? Is because these other pods are not run via any controller, any controller, including replication controllers, etc. This is being run by a controller, and it is being watched for, even though there is only one pod, it is being watched for. Let me delete this pod called as DB as well and show you again that this once deleted is gone and it's not coming back. It's not high available. It's neither scalable. Okay, so there are some questions from YouTube stream. These second sessions are available on YouTube, so these are automatically recorded. All right, if you want to discuss, you can get in touch with over the email and we'll get in touch with you. Ashish has a question about, all right, so Ashish had a problem earlier. So we moved to YouTube Live because of the technical issues on the first day and the first session. So this is definitely going to be a better experience for you. Okay, talking about controllers now, coming back to that, I'll take the questions a little later again. And if you have questions from anyone from the Zoom, you can just unmute and speak as well. We'll address it immediately. Availability and scalability, how do we achieve that is via some sort of a controllers. How does it work is right now, this is what we have. Let's say if I have 3 different applications and if I want to run multiple instances of it, maybe they're deployed on different nodes. Right now, if let's suppose the node is down, it brings all the pods along with it. And at that time, the application and the pods will be affected and it will basically be down, right? So it will be down and that will affect the uptime of my application itself, right? However, if you're running it via some sort of a controller, let's suppose there is a replication controller associated with it. What would happen in that case is instead of this application going down, the replication controller will keep on watching for the pods, and it will automatically ensure that the pod comes back up, maybe on a different node. So same thing happens, the pods are down, but it comes back up on maybe on a different node altogether. That's how the replication controllers work actually, right? And when you talk about replication controllers, how do they monitor for these pods and their availability is where the importance of labels and selector comes in. Even last week, when we talked about writing the pod spec, I mentioned about, let's say, the metadata, mainly the labels, which are important because it is the labels based on which there will be the controllers will be watching for the availability of certain set of pods. It will basically be watching for the pods with certain labels, and that configuration, what labels and which pods, how do you narrow down the pods, how do you filter the pods, that is called as a selector criteria that you apply to the replication controller. The replication controller will keep on watching for the pods with certain labels, and that's how it knows that, oh, these pods are available or these pods are not, and how many are available. And if it finds that, and you also define how many, right? So you define the scale, you define the selector, which will be responsible for the availability. So it will ensure that X number of replicas are always available with certain properties there. And if it does not find it, it will try to launch it on its own. And that's where it uses something called as a template. So the replication controllers keep on watching for the pods with certain labels, and that configuration that you apply to replica set is called as replication controller, is called as a selector criteria. So let's suppose the pods have these three labels, so card, app, version, and environment, but your selection criteria may be using fewer labels than that as well. That's fine, because you don't care about the version, you just care about the app being cards and environment being dev, and any pod that matches it, you're going to consider that is part of your own pool. And you'll start watching for it. So labels and selectors are very important. Metadata is extremely important in the world of Kubernetes, actually. And that's how it maintains the availability. Now, there are two controllers, two replication controllers. One is called as a replication controller, the old one, and the newer one is called as a replica set. Now, what is the difference and which one do you use? Talking about replication controller and replica versus replica set, there's a very slight difference. And that difference, if you technically look at the difference, it is more about the way selector criteria can be defined. Whereas replication controller can only do this and that, right? So it does ending. So it has to match all of these in order for it to narrow down and find those set of pods. Versus the replica sets have a much granular control, or it has a better control over flexibility rather over the selection criteria, because you can do this and that and one of these three, right? So it's, you can define a set of values and select based on that set, or deselect, exclude based on that set. And that's probably why it is called as a replica set also. It's a set of replicas, and you have a set based criteria as well to select those set of replicas with replica set. But beyond that slight difference in the selection criteria, there is something more to it. And that something more is about, not only about providing the high availability and scalability, but also how do you go from one version to another. When you start rolling out the new versions and deploy those with replication controller, there is no way to add that code, the strategy to roll out as the code, as a YAML code. So it cannot be programmatically done. Whereas with replica set, you can add the code in the form of an update strategy. And when you do that, you take the replica set, you add the update strategy code, what you get is a deployment. So with replica set, this is just a manual or imperative approach, versus with replication controller, that is a manual approach, versus in replica set, you can codify it and you get a deployment that way. And if you look at the deployment, it is nothing but a replica set plus that update strategy. And replica set internally maintains the set of pods using something called the pod template. So when it does not find enough pods running, it uses that template to launch the pods. That's how we will start launching the pods from here on, actually. right? And this is a spec example of a deployment where you see the replica set or replication configuration. And then on top of that, you just have a strategy part, which talks about how do we roll out the version. And that is defined as a code as well. Now we will talk about deployment later. So today is mission number 3. In mission number 5, we'll discuss the deployment. But right now, we'll build up the knowledge up to the replica set and learn how to achieve the high availability and scalability using just the replica sets alone. So last week we discussed about the pod spec and we talked about how to create the pod and so on. This time we're going to use a controller called as a replication controller and start writing the spec to deploy the pod using that sort of a replication controller as well, right? We'll come to that in a bit. Before we start using the replication controller and replica sets, right? There is something else that we want to do, and that is we talk about namespaces as well. Why namespaces is because let's say as part of these labs and this 90-day challenge, we will deploy an application, an entire application stack called as an example voting application, which is a microservices stack. Now imagine you're an organization where there are 20 different projects, maybe 5 different engineering teams running those 20 different projects. Now, when you log into this cluster and connect to it, and if you list the set of pods, if you see the pods all across the project, like hundreds of pods, one is you're going to get confused. Second is a lot of things are not going to be relevant to you. Third is you may accidentally overwrite somebody else's work or step on somebody else's work or delete someone else's work, and that's going to be disastrous, right? So you want to isolate the project deployments and only provide access to the teams which need it, and also set the views accordingly so that not everyone has access to everything at the same time. You have these compartments and you go to this room and you work on this project, you go to that room and you work on that project. So it should work like that. How do we compartmentalize it? How do we isolate it is where the namespaces come into play. So what are the namespaces? How do they work? Let's talk about that first. Okay, so the way namespaces work is, let's say we have this application to deploy. Let's take the same application, 5 microservices to deploy on a Kubernetes environment. And let's say you have 3 nodes or 4 nodes. Right now I have these 4 nodes, for example, right? And instead of managing these nodes individually, I have connected them together and formed a cluster out of it. And to this, I can add 40 or even 400 nodes later when I want to add more capacity. And what I'm talking to are not those 4 nodes, but a cluster to which I'm submitting the workloads to. So this cluster is like a logical thing to which I'm submitting the workloads, is the cluster that we're talking to. So when I run a command such as, oh, show me the pods, I'm not bothered about which node it is running on, or I'm not bothered about which node, how, and so on. I'm just listing all the pods from the cluster or a particular project, and that's what I'm more bothered about. So we have already formed a cluster, which is the logical entity, and that one logical thing is what we are talking to. And we can then partition that or compartmentalize it into different projects, different views, different compartments. And those compartments are called as namespaces. Those provide us with a level of isolation. And a good way to compartmentalize it is based on projects, but you can also do it based on like organization, business unit, departments, environments sometimes, and so on. So all non-prod environments are running in one cluster. So dev is here, QA is here, UAT is somewhere, and you can compartmentalize that way as well. So it's up to you. A good way to do it is based on the project. So for example, this is a project that we're working on called as InstaVote. So for InstaVote, I could create a dedicated namespace. That way, when I'm connected to the cluster, I'm only looking at all the pods in that namespace or for that project. When I switch to a different project, or let's say you are working in a different team and you're connected to the same cluster, but you get a different view of the cluster than what I see because we may be in a different namespace or working on different projects. That's what you want to do actually, right? And how do we do that is with namespaces. And we are going to create a namespace at every project and then switch to it and switch between that as well. Now, namespaces offer you this logical views and separations. Namespaces also serve as a scope for the authorization rules. So you can define access control and say that, oh, this particular project, these people have access to. And it could be read access, read write access, and whatnot. You can define network policies and define how application in project X can connect to application in project Y. You can define quotas and resource quotas, object quotas, etc. And based your multi-tenancy work on that as well, right? So namespaces serve as the foundation for the multi-tenancy as well. So I'm going to create a namespace for this project because everything that I deploy for this project, I want to do it in its own namespace. How do I create a namespace and switch to it is where I will start talking about here. And right now, if I show you, when I list the pods, I see the pods from one specific namespace. Okay. I'm going to start watching for the pods in my current namespace. I only see one. Which namespace I belong to? How do I find out? How do I find that kind of a configuration? Is using kubectl config get hyphen contexts. Context with S. It's plural. Okay. This lab guide is what I will be sharing with you. Let me share that on the Zoom. This is for the replica sets, etc. And I've shared it on the YouTube chat as well. All right. So let me create a namespace and switch to it. Which namespace I belong to is default. How many namespaces are there? Let me show you that. So get ns or get namespaces will show you there are these many namespaces. These are created by default by the cluster. This one was created as part of my setup. I used a tool called as Kind, K-I-N-D, Kubernetes inside Docker, and that has created a storage namespace on the top. But these are the ones, and by default, I'm connected to this one. That's the default, right? Now, when I listed the namespace, or when I showed you what is the namespace I'm connected to, I didn't list the namespaces, but I listed the contexts. Now, what is this context? Let's talk about that. This is a very important concept because especially if you're gonna work with the exam or prepare for the exam, this is something you must know about. In exam, you may have access to multiple clusters. Let's say there are 3, 4 clusters, or let's just imagine you're a developer and you have your own workstation. And from there, you have access to different clusters. One is prod, one is staging, one is dev. Okay. Now, at any given point of time, you can be connected to only one cluster and work with it. So you're either connected to prod or stage or dev. And this is just one dimension, prod versus stage versus dev. The other dimension is the user. You're connected as some user. You may be a dev user with certain access to certain namespaces and other restricted access to everything else. You may be an ops user who has a wider access to the same namespace. So you are either connected as a dev user to the prod cluster, which let's say gives you a read-only access to a project. But when you switch to ops user, you get a read-write access to the same namespace or a project. So that can also be a context switch. So you will be, what is a context? Context is a combination of a user and a cluster. So X dev at prod is one context. Dev at stage is one context. Dev at dev is one context. Similarly, dev at prod versus ops at prod, same cluster, but different user means a different context as well. So how do you switch the context? How do you list the context? You can list the context this way. If you have multiple contexts, then you can switch between those. And then you can say config use context. And let's say you're given 2 clusters, cluster X, cluster Y. So you will say cluster Y is what I want to connect. Cluster X is what I want to connect. That's the context name. Or cluster Y is what I want to connect. What is my current context name? It is called as kind-kind. And what cluster I'm connected to, auth info is the user. So this could be dev at prod. Prod could be cluster name, auth info, but right now it's the same name, but this is the username. This is the cluster name I'm connected to. And this is the namespace within that cluster. So the namespace is within each of the cluster. Let's say I'm connected to just one cluster. And since I have only one cluster, I'm not switching any, but you should know about context switching. That's why I showed you this. And uh, within this same context, I can switch the namespaces. And that could be my product X versus Y versus Z, or maybe a control plane versus default versus insta-vote. So you can create the namespaces and switch just the namespaces also. That's what I want to do here, because I have only one cluster, but I want to partition it, compartmentalize it based on the projects. And for this project, I will create a namespace and switch to it. How do I do that is quite straightforward, actually. kubectl get ns. I don't see the namespace for instavote. I will create one, create namespace called as instavote, and that's it. I can write a YAML for this, but I can just do it this way as well. And I have a namespace here called as instavote. Now, creating a namespace does not mean you're switching to it. You have to explicitly do that by using a command such as kubectl config all right, set context. Yes, it's a set context command. And here I will not be switching the cluster, neither be switching the cluster nor the user. So in my case, I would just say current. So I'm connected to the same context. I'm not switching the cluster. I'm not switching the user. So current context, but I will be switching just the namespace. To what? To instavote. And observe what happens in the bottom window. As soon as I switch my namespace, I get a different view of the cluster. In this view, there are no pods running because I just created a namespace for instavote. Nothing inside is running yet. But I can do this. I can list all the other namespaces, and I know that there is one particular namespace called as kube system, which has some control plane pods like my scheduler and API server and so on. So I can switch. Before that, let me show you by listing my context also, where I see that I am now connected to this namespace. Everything else remains the same. Let me switch to kube system namespace. So I'm switching only the namespace. Observe that only the namespace. That's it. Nothing else changes. Context is the same, just switching the namespace and see the view change in the bottom. Now, whenever I run any command, it is applicable to the current namespace mostly, right? So when I'm listing something, get pods or deployments or whatnot. And then I can go back to my instavote namespace. I can go to the default namespace, right? I have one more namespace, local path storage. Let's see what is in there. So this shows me a different view, a different pod, and that's how it works. So kube system, if I go back to that, I see the control plane. If I go back to instavote, I have nothing. And that's fine because I want to start with that blank state. And inside that, I would want to launch my replication controller and achieve the scalability and availability. Before I launch that though, I am just launching one pod in this new namespace using my previous code in this directory. And if you're following the labs, it's the same code that you have created and worked on last week. And I have one pod running and I'm watching for that. I will also list the labels here because labels are very important. Observe the labels, observe the pod here. And now I will begin creating the replica set configuration that I spoke about earlier. I want to achieve scalability and high availability. How do I do that? Is using this replication controller, which is what I talked about earlier, right? So I have a controller. I will write the spec where I'll write a selector that will control the availability, and scale is controlled by another property. Now, what are those properties that I need to write in a replica set? To understand that, we go back to API reference document, just like always. I did mention to you that if you want to master Kubernetes, the way to do that is through this API reference document, which is very, very useful and important. So let me launch it here and show you what we're talking about. I want to create the spec for replica set. If I go to the replica set, I see the properties. You have this AKMS part, API version, kind, metadata, spec, status, etc. Right? So mainly API version, kind, metadata, spec, AKMS. If you look at the spec for the replica set, it has only 4 properties, very simple. And out of that, one, which is template, is something that we've already seen. So I'm going to start switching to the namespace. So the way I organize my code, I'll be here. The way I organize my code is with projects. So I will go to KTS code. I have a subdirectory called as projects. This is where I keep all my projects. Let's say I'm working on these 2 projects. I'll go to instaboot, the one I'm working on right now. And then I have different directories for different environment specific code for now. And then I'll go to this dev environment. And this is where I see my vote-rs.yaml. So the convention that I use to name my files is the name of the application followed by the object, like in this case, replica set rs. ing will be ingress, HPA will be horizontal pod autoscaler. This will be service and so on. So vote-rs is what I'm going to write my code inside. And this, if you look at, has already some scaffold. So there is a AKMS part that I taught you about last week. Yeah. And then if you look at the kind will be replica set, metadata will be there, spec will be there. Spec already has a template. If you look at this on the chat, can you write in what this spec is all about? Have you seen this before? What is this referring to?
It's just a pod definition, pod template.
Absolutely. This is a pod. So when you say template, it is always a pod. It's a pod template. Okay. Why are we defining this as a template? And what is a pod template? Why pod template? Why not reference the pod spec that we've written earlier? You don't reference that anymore. And the reason why we're defining it as a template is because, as I mentioned to you, replica set will keep on watching for the available set of pods. And if it finds it not being available, it has the capability of launching it or submitting it for launch. How does it do that? It uses that template and just takes a name from the template. Let's say adds, when it names the pod, it will use this as a prefix, add some hash to make it unique, and use the properties in the template to launch the pod with. So it will create like X number of replicas of the pod using this template. You will no more write the pod spec separately from now onwards. You'll write it through template, be it replica set, be it deployment, be it stateful set, everything, be it job, cron jobs, everything is going to have a template from now on. So when you say template, everything inside template is just the pod spec. You remove the A and K part of the pod because it's no more a pod kind, or so API version also is not applicable for the pod. It is gonna be a different one. So you just add the metadata and spec from the pod spec. That's it. It's already taken care of. So my one spec is gone. I don't have to worry about that. Template is just that. Uh, Minimum ready second, we don't have to worry about that right now because this is only useful in deployments case. So we are only left with 2 properties, replicas and selector. We're talking about replicas at spec. Template is covered because we talked about it separately as part of pods. And we are left with replicas and selector. Replicas is very simple. It just how many pods do you want? How many replicas of what? You are replicating only the pods. That's the unit of replication. That's the unit of deployment. So how many replicas of pods? How many you want? The scale. So replicas is responsible for maintaining the scalability. Selectors are responsible for availability. Why selector? What are selectors? We just spoke about it. Selectors is how the controller will know which pods to monitor, how many are available in the current namespace. And based on that, it will make a decision whether to run some more, whether to delete some. All of that happens based on the selection criteria. So selectors are responsible for your high availability fault tolerance features, basically. And those are the things that we'll add here. So I'll show you how to do that. I'll take this vote-rs.yaml and start writing the spec for it. The API version is going to be not just v1, but it's going to be apps v1. Okay. Why apps v1? You can find out the actual APIs are, from here. So kubectl API resources, this is a very useful command. Shows you not only what resources are available, including, let's say, replica sets here. It also talks about what is the API version, right? It's apps v1, no more just v1, because v1 is only for the core APIs. Everything else needs a name like apps v1 here. So you have to define it like apps v1. Okay, let me also talk about deprecation of APIs here, because this apps v1 used to be extensions v1. Let me show you that. Sometimes you'll see the code like this still has this apps v1. So sometimes you'll see the code with extensions v1, beta1, because this is what it used to be in the previous versions of Kubernetes. This replica set started as an extension, and then it was converted into apps v1. So that was deprecated, that API configuration and that entire API group was deprecated extension, and it was renamed to apps. When that happened, what happened was a lot of times uh, we had legacy code, and let's say it was extensions v1 beta 1. We'll find out what happens if I keep it to that, and that will help you understand what happens with API deprecations and stuff like that. So kind is going to be replica set with R and S capital. I'm just copying and pasting it from here. Metadata, the name for the replica set is going to be vote. Labels just for the filtering of replica sets. These are the labels for the pods, which are very, very important. And you need to pay attention, focused attention to that. And then replica set has two properties that we need to add, replicas and selector, as I just mentioned. Replicas and selector. Yeah, that's it. Now, if you look at replicas, it is an integer. So it's very simple, just the number, how many you want. Let's say 4. That's all really is. Selector is slightly something that you need to practice with, because selector is a label selector, and it's kind of a dictionary of sorts with multiple properties, and you have match labels and match expressions. So let me write those properties here. Match labels, you have to indent it, and the match expressions. Match labels is a object, match expression is an array. Okay, this is going to be slightly, it'll take a bit of a time to figure out. Okay, and what are we talking about? We are writing a selector where we are selecting based on what? Based on the scope is labels. You can't select beyond that. It's just the labels that you can select from. So what are we selecting now? So I'm going to use since it allows us to have an expression or a set-based selector, that's what a difference between replica set and replication controller is. I'm going to define a criteria where it says X is equal to ABC, Y is equal to PQR, and the version is one of the values in a set. So set-based selector. So how, if I have to define that, how would I do it is, out of these, I will say app should be Python, role should be vote, version can be any of v1 to v5 or v1 to v3, let's say. If I have to write that, the label matching will come in here. So you do this and role should be vote. So both have to match, and then the expression would have these properties. If you look at the expression, it's an array, and each of that array item can have key, operator, and values. Let me write those. Key, operator, values. This is one expression, okay? That's why it starts with hyphen and it continues with all three at the same level. What is the key that we are talking about? Key is nothing but the version. So we're defining the version, saying that the values can be any of these v1, v2, v3. So I just defined a set of values. So you define a set of values, version has to match that. So to match it, you have to use an operator. Operator can be one of the four: in, not in, exist, and does not exist. Only four things. How does it work? So in will mean version can be v1, v2, v3. Not in is just the opposite. We are excluding v1, v2, v3. Anything else is acceptable for me, right? So that's what not in would mean. Sometimes you don't care about the actual values. So let's say I don't care about the values. The version has to be present. So I will say it should exist. Yeah, exists and does not exist. It's just the opposite of that. So in my case, I'm going to keep the criteria as this, where I'm going to say, okay, app should be Python, role should be vote, and version X should exist. If it matches these three criteria, I will consider it as part of my own pool. Remember, even this pod that I've created outside matches that criteria. App is Python, role is vote, version exist. It's just going to watch for this right now, replica set. Okay, so replica set, let me review this one more time. I've just given extension v1 beta 1 just to show you what happens. Kind is replica set, metadata I've defined. In spec, I already had template, which is the pod properties. If I want to add any properties to the pod, I would add it to the spec part, template part inside the template. And then with respect to replica set, apart from the template, we have number of replica, just a number. Selector is how many. Select replicas is how many. Selector is that criteria, which will watch for the pods. Now, let me create the replica set first. I'll do a dry run on the server side. Okay. So this is what happens here. So it says extension v1 beta 1 does not match for the kind replica set. Why this happened, and this started happening because if you had a legacy code and when the API was deprecated, the extensions, and it was moved to apps v1, you had to be mindful about it and you would have to make a change accordingly. Otherwise, you would keep on getting errors like this. Uh, Fix is very easy. Fix was very easy when that happened actually. And all you had to do was look up your version of Kubernetes. And here it says v1. It's not v1 beta 1. It says apps, or let's say replica set. It says apps as a group, not extensions anymore. So if you had seen, maybe, let's see if we can still find older versions of replica set. Not available anymore. Nope. So at that time, there was extensions v1. Now it is apps v1. So all I have to do is change this to whatever it matches in my documentation, apps v1. That's it. Doing a dry run one more time. Looks good. And let me go ahead and apply. Observe what happens on the bottom. Observe what happens on the right, because I'm launching a replica set, which is going to create 4 replicas of that pod and find out where it runs, right? So there are 2 running here, 1 launched here somewhere. I can filter it from here also. There's 1 running here, 1 running here, 2 here, right? And then it launched only 3, not 4. Look at the age. It's been running only for a few seconds. This has been running for about 15 minutes. This was created outside of replica set, but it matched the selection criteria. And since it did, it is considering that as its own. And accordingly, it only launched 3. And let me watch for not only pods, but also replica sets now. Yeah, this is the replica set, which defines the desired. Desired is what we define in our spec. Current is whatever is available currently, which is 4 right now. When we started, it would have been just 1. And then it tries to match that number by launching, deleting, whatever it needs to do. And then ready is after finishing the health checks. If you have defined any readiness probes or health checks, it will mark it as ready only after the health checks pass. And that is the signal for it to receive the traffic as well. That's how this works. All right. Okay, so there's a question I'm going to take from Navraj. How does namespaces and C groups on Linux kernel different from Docker and Kubernetes? So namespace is a concept you'll find everywhere. There are kernel namespaces. There are container naming namespaces like image namespaces. This is the namespace at a cluster level. So you're defining or partitioning the cluster into different compartments, and that is the namespace we are talking about in Kubernetes context, right? So namespaces in general is a way to isolate or compartmentalize things. And in case of this, this is at the scope of, running that product and everything related to that product, you will run it in one specific namespace. But also, if you look at kernel namespaces, it's isolation, but at a different level. That's at creating containers and so on.
Hi Gaurav, Santosh here.
Yes, Santosh.
Uh, the right the right hand screen that you're showing boxes with the graphical thing, right? It's a custom app or is there something we can use or
It is something that I demonstrated last week, and also there was a lab for it. If you had attended that session, so this is called as a visualizer, and it's a third-party open source application. You can set it up the same way. So whatever cluster I have, you can set up the same cluster and same visualizer, and I use it in all my courses and trainings as well, which is a very useful tool, especially the things that we are doing right now. And when we do deployment, it's very useful to understand what's going on with that tool. So it's I call it as a visualizer. It's called as kubeops view, and the code for that and everything is already been shared with you. You'll also find it on our portal. You'll find it as part of the course and probably a part of the labs as well.
what is this tool called? CubeOps View.
Kubeops view, that's right. That's the one.
Okay. Thank you, Gaurav.
Okay, there's a question I'm going to take from the Zoom session from Atul. Is match expression mandatory? It's not mandatory. If you want to provide it, set-based values, it is something that you can use. Otherwise, you can also just use match labels and do with it, no problem. But you have to define that structure and that schema that way. If you define the labels, it has to be in the form of the match labels only. You can just define this much though. Don't have to write an expression if you don't want to. Michelle has a question. I'm familiar with namespaces, but not with the context. Could you tell us the importance of use case? Context is basically switching the cluster. You are a developer and you're working on different clusters. Let's say there's a production cluster, there is a staging cluster, and then there is a dev cluster. You cannot connect to all the clusters and run the commands on all the clusters at the same time. From your workstation, you can only connect to one cluster as one user at a time. And that's the context basically. Imagine in case of an exam, you would be given like 4 different clusters. And there is an issue with that cluster, which is related to problem number 5. And problem number 10, you will have to switch to a different cluster because there's a different type of an issue with a different object. So you'll have to switch between that as well. And that is where context switching becomes useful from the exam point of view. And in real life, this is what you do. So you have different clusters and you can connect to, let's say, a production cluster is running on cloud, on GKE, versus my staging cluster is with a data center, and my dev environment is my local environment. I can work with all of these by switching the context, but I can only work with one cluster at one point of time as one user. That is the context we are talking about. Prod versus stage versus dev could help you understand that better. Amol has a question. Can we create multiple contexts for one cluster? And yes, and how? For one cluster, you will create a context, different context only when it makes sense, only when you are connecting as different users. So dev at prod versus ops at prod. So same cluster, but you're connecting as different user because you have different authorizations. So that's when it makes sense. You don't have to switch the context just to switch the namespace. You can be the same user and same connected to the same cluster, but you can just switch the namespace also. Like I showed you just a few minutes earlier, That would make more sense if you're just switching between the projects. But if you want some different authorization, connect as a different user to the same cluster, only then it makes sense to do that. But it is possible to create a different cluster, different context for the same cluster based on user. Atul has a question. Can we use kubeops view tool in real industry, or we're using it for practice and training purposes only? I use it for training because that's the primary thing that I do these days. But you can also use it in your environment, real environment as well. I don't believe it has a capability of modifying anything. So it's more of a read-only thing. And you can define your RBAC authorization accordingly as well. So it's possible to use it in real life project as well. Okay, so I've created this replica set, which has launched a set of pods, 4 pods specifically. And now I'll show you the scalability and availability features of this replica set. What is possible, what is not possible, we'll talk about both. Let's talk about availability first. If I list the pods, look at the age of the pods, okay? Because that's when you'll see the difference. And it has used the template. So to create the pods, it has used the template. So template is the vote, had a name vote. So it used that as a prefix, and it added a 5-character suffix to make the name unique. That's what it has done. Now let me delete some pods. I'm deleting 2 pods. And see what happens. You'll see it in the bottom. You'll also see it on the right. As soon as I delete the pods, terminating, you see a couple more created just a few seconds ago, right? It just got created. And that's what happens because there is a controller now watching for the availability of the pods with certain set of labels. As soon as there are 4 pods with those labels available, it's fine. The moment it detects a discrepancy, takes an action. It's immediate, almost instantaneous. Observe this now. I'll do it one more time. Deleting this and this pod now. See what happens. It's almost instantaneous. It was just watching. It runs in something called the control loop. It's running in a loop, watching for the pods with that criteria. The moment there is a change, it takes an action. And it keeps on doing that. That's how you get that resilience, fault tolerance available. And it could be because of a node issue. It could be someone intentionally deleting it. It could be because of some eviction happening is because of the overload of the server and so on. In any of these situations, the controllers will come in and do their job for you. That's just amazing. And it's very reliable. It works very well. Let's talk about scaling also. So if you want to scale, you have a couple of commands with kubectl. One is scale, second is autoscale. Let's look at the scale command first. Okay. With this, you can manually scale the replica set. In this case, we have replica set. So let me scale it. So if I want to scale the replica set, whose name is vote, I will define the scale also. I'll say, okay, I want to scale it to 7. See what happens. Almost instantaneously, it launches 3 more pods, and within a few seconds, it should be all ready. And this is amazing. And you can go from 7 to, I'm going to go from 7 to 12. I wouldn't suggest more than that though, because this is a setup which is a limited setup that we have done with kind Kubernetes inside Docker with limited resources. If you scale too much, we don't have control over it right now in terms of resources and all that. So it will just try to spawn it off and it will bring down your nodes and cluster also. That can happen. But if you have resources and a real cluster, you can scale it to like hundreds of pods also. And it does that within seconds, not like minutes, unlike VMs. I was already, when I started with this cloud, and what drew me to AWS cloud back in 2007 was this auto scaling feature, which was launched. And then it was just fascinating for me. But if you look at it right now, it's just amazing what you can do, because even with VMs, when you scale, it works well, but it takes minutes to have your new nodes into action and serving traffic. Here it's seconds, which is just amazing for scaling. So for your application, their uptimes, their SLAs, this it just serves much, much better compared to VM. And it's not just scaling up, scaling out, it's also scaling in. So horizontal scaling we're talking about. That's the best way to scale anyways. And I can go from 12 to 8 in a few seconds. So it just changes the desired count and accordingly it matches the current. In this case, it deleted some. Which ones will go first? The ones created the most recently are the ones deleted first. Because if you look at the oldest one, they're still there, right? So that's how it works. And I'm gonna go back to 4 pods. Let me also show you that it is also considering that pod that I created outside of replica set is as its own, because if I delete that pod by name just vote, it will also be replaced with a new pod. And from now onwards, it's just launching its own with its template and so on. So that happens automatically. So replica sets give you scalability. Just showed you manually. I'll show you autoscaling also in a few minutes. And secondly, it gives you the ability to uh, provide high availability, basically, right? So high availability, scalability, it does both. The one thing that it cannot do is start rollout on its own. That's when it has a limitation, and that's why we need something like deployment. Let me show you that. So if I update something, I'm using kubectl edit. Now you can use edit command to edit a live object from a cluster. So it pulls the object from the cluster. So edit replica set whose name is vote. And then I'm trying to update the image and also update the labels. Okay. If I'm using an edit, it is all instantaneous. The change will automatically happen instantly. Let me show you that. So kubectl describe the replica set. Currently it says v1 here in the image and here as well. Shows me all the events all. But look at the configuration. It's still at v1. The moment I save it, I've changed it to v1. I'm saving it. The moment I do that, the configuration gets updated in the cluster. So it is set to v2. Sure. But it's not taking any action, as in it's not rolling out a new version. It's not replacing the previous pods with the new ones, because it is not capable of doing that. That's when you need the strategy. That's when you need deployment. And that's when I said that replica set plus the update strategy like this. So how do you roll out and all that? That is the update strategy. So you take the replica set, you add the update strategy, and you get a deployment. So when we talk about deployment, it's just going to be about strategy. Very simple, very straightforward. We would have built the foundation for it already. Okay. That's how it works. And it's not capable of rolling out a new version. However, if I, let's say, delete a pod, and then it will replace that. When it does that, it's going to launch it with the whatever the current configuration is, which is v2, and only that pod will be running with version 2. Okay. And then if I scale it, I'm scaling it to 6, then it has to launch 2 more. That will also be running with version 2. So only in case it has to create new pods, it launches with the new version or whatever the current is, but it does not by its own go and replace the previous pods. And that's where you need a deployment. Not just replica set alone is enough. Okay. So that's the limitation of replica set, but it does give you the availability, scalability. And when you use deployment internally, it will create a replica set, which we will look at later when we go to deployment. But that's what happens with replica sets. It is capable of handling the scalability, availability, and that's it. It does the only 2 things, but it does it really, really well there. Okay, any questions with replica sets so far? I'll take pause here to take a few questions before moving to auto scaling with horizontal pod autoscaler. All right. There's a question from Michelle. Is it a good practice to have different contexts for a group of users? Is context the only way to apply cluster authorization? No. Uh, Context is a way to switch between a project and a user, or cluster and a user. That's what it is, and that's all it is. Authorization rules are defined using RBAC policies. For authorization rules, namespaces are important. So let's say authorization rules, you can define that, hey, who has access to project X and project Y, or project A and project B, this group of users. So you can create users and groups, which is a different thing. Context is just for switching and connecting to a particular cluster as a particular user. That's what it is all about. Authorization rules are defined with RBAC policies, and there you define that, oh, this user or this group of users, you can define that based on a group and based on a namespace. So scope can be the namespace, project X. Okay, so this group of users has read-write access to project A, but they don't have access to B and C. There's another user group called as Y that has access to C and B, but not A. So you can define that kind of access control based on access control with authorization, RBAC policies. The scope is namespace, and the subject can be a group of users. So you apply the policy to a group of users. That's how you do that grouping, right? So creating users and groups is an independent thing. Authorization is a different thing, and context is a completely different thing. But you have some namespaces in common everywhere. So namespace serves as a scope, and with context, you can switch the cluster and the user. But within one cluster, you can also switch the namespace. There are context-specific commands which will help you do that, but it is not directly related to the context. Okay, there's a question from Navraj about how does namespaces and C groups on Linux. Okay, that's addressed. Is there any rules or policy when I can scale my workspace, like until that condition gets smashed, my scaling? We'll come to the auto scaling policies and what could be the policies, some default ones, and what else is possible. We'll talk about that. Gopal asks, will it be possible to set scale quota? Quota is a different thing. So quota can be applied on two things. One is the number of objects that you can create. You can apply a quota at that level. So that's a object quota. And second quota is resource quota, like how much of CPU. So for example, I have 1,000 cores of CPU available in my cluster. I will say project A gets a quota of 200 cores in total. Product B has 400 cores, product C has 300 cores. That's the quota. That's the resource quota in the form of cores and memory, CPU memory, right? Object quota is how many deployments can run in namespace X or for product A, that is, right? How many pods can you create there? How many volumes can be allocated to you? So that is the object quota. So quotas are at the resource or object level. Scaling wise, it's not about quota, but it's about range. So you define the minimum, you define the maximum, and that's about auto scaling. So these questions about the range and about the policies, I will address it in a horizontal pod autoscaler, the next topic. Dinesh has a question. Uh, in case two have access to delete pods, how would I know who deleted the pod amongst the two? You will have to do some audit trail and monitor the request APIs coming into your basically to the API server. So you'll have to maintain some sort of a audit trail to find out who deleted what, right? So that's probably what you'll have to do. Access control is different. Audit trail will be a different thing. Okay. Any other questions on replica sets? Because I'll address the auto scaling configurations next. So we talked about scaling. Now let's talk about auto scaling. Okay, is there a vertical? There is another question from Navraj. Is there a vertical scaling policy? Well, we talk about horizontal pod autoscaler, which is the default autoscaler. However, there is some Kubernetes vertical pod scaler as well. Okay, so there is some. So you have some configuration here as well. EKS is a different, EKS is gives you that, but you do have something where you can use a vertical pod autoscaler as well. Now, what is a vertical pod autoscaler? Vertical pod autoscaler will just increase the number of resources which are given to you so that you can get more and get more resources from the chunk and so on, right? So that's more of a vertical pod autoscaler. So there are tools and there are controllers, not like official direct ones. I don't believe this is an official built-in controller that is a VPA or vertical or autoscaler, but it is part of this. So you can try checking this out Just search for vertical pod autoscaler and look that up. Let's first understand what is horizontal pod autoscaler first, though. That's the default autoscaling in order to even try and understand the rest of the things there. So horizontal pod autoscaler is a simple thing. It's a autoscaler of pod. It launches multiple replicas based on certain policies. And what you define is you define the range. With the autoscaling, always you have these configurations. Where is my point? Yeah. So you have some configurations like, oh, what is the minimum? What is the maximum? What is the desired? Generally, right? That's the range. So you define the limits. These are not limits, but the range sort of the minimum and maximum, along with the desired is how what you launch with, start with, and then you can go this way or go this way based on the policies. The policies can be what? By default, you have resource policies like CPU and memory, right? Those are related to resources. Earlier, it was only about CPU. But you can add additional policies. Where does this come from? Is there is something called as a metric server, which you can run in Kubernetes, and that gives you this information by default, right? That's what you can use for the scaling policies to start with. And then you can also add custom metrics. Custom metrics can be anything. You can use anything, any criteria. It could be length of your queue. It could be the latency. Latency is a very useful thing to have scale on. Latency, if the latency goes up, meaning your requests are slowing down and you need more capacity to serve it. So it's a very good indicator for scaling. So you can use based on that, and you can do a lot of things with custom metrics. And any criteria that you want, you can feed it in to Kubernetes, and then based on that, you can scale. What I'm going to show you here is auto scaling based on this default resource configurations available in the cluster. How do you find out the monitoring data and this metric server information and all that is, if you look at kubectl command, there is one command called as kubectl top. Yeah, and it has two options, top for the node and pod. So this shows some monitoring information related to nodes and the pods. Okay. So you can do top nodes or top pods. Pods should also work. So right now it says metrics API not available because you have to deploy this. Okay. And it keeps on, the official version of this keeps on breaking all the time. So you have to keep on fixing it. I just managed to fix it today, one version, and that's what I'm going to deploy and show you. I've updated the lab accordingly though. So it should work if you try this auto scaling lab ideally. Okay. We'll figure it out. I'm sharing this lab with all of you. All right, note it down. Okay, so metric server needs to be deployed first. You can also look at the architecture diagrams here. So if you go to the towards the end of the lab, maybe it's broken now, but there used to be an architecture here, monitoring architecture, and some metrics pipeline. Most of these links are broken now. I'll try to find the resources now. They've moved it or removed it and so on. But metric server gives you the monitoring data related to node and pods. So when you have metric server set up, your top commands will start working. I will show it to you once it is deployed. How do you deploy the metric server? Okay, I fixed it already for you. So all you have to do is just run these commands and wait for a few seconds, few minutes, and I'll be watching for the metric server here. So you can see it's bringing, launching that metric server, this part. And let's watch it. Yeah, it is running already, so it should be up. And let's see if we have the data. It takes a minute or so to have the data in. It's already in, top parts, top nodes. So what are we talking about? CPU, memory, you can scale based on this already because you have access to this data through the metric server. So you need to launch the metric server, and it is monitoring how much of CPU, how much of memory is being consumed by the existing set of pods. Not much you can see already, right? But I can define some scaling criteria. And when I say auto scaling, we're talking about horizontal scaling mainly in the context of Kubernetes default scaling. And horizontal scaling is about increasing more capacity, meaning launching more replicas. So either you launch or you reduce the number of replicas when you want to scale. Right? And you can put that behind a load balancer and whatnot also later. So how do I define that auto scaling is you can always use this kubectl auto scale command also. There is an auto scale command. I showed you that. There is a scale command. There is an auto scale command. Yeah. And with what can you scale? Deployment, replica set, stateful set. We already have replica set. We'll scale that. And with auto scale, you can check what options are possible by using minus minus help. Okay. And you'll see some configurations as well, like, oh, you define the minimum, you define the maximum, you define the desired, you can define the scaling policies and all that. Now, this is a very simple, basic, rudimentary policy. Now, the auto scaling has moved on to a much sophisticated configuration, which is what I'm going to show you today. Because if you look at Autoscaler, that is one object which has gone to the V2 version of the API. This is the first object that I've seen with V2, version 2 of API here, because most of that is still on V1, so except for horizontal autoscaler. So horizontal pod autoscaler has gone through overhaul, almost like a complete overhaul, and it has a lot of new properties added to it, and that's what I've created. I've created a sample code which I will share with you. You already have access to it, and you can create a policy like this. I'll explain what this is, but I can create a policy like this, and based on that you can experiment with it on top of that as well. So if you have to write a policy, how would you go about it? uh, Using this API reference, it is basically AKMS. So you start with API version kind metadata spec. In the spec, you define the minimum and maximum, right? How many you want as minimum number of replicas, how many maximum you can scale up to. What do you scale based on what, right? So the policies should be based on some metrics. Okay. So either it could be pod specific data, like this pod has this much of CPU. This is good, right? So this is fine. But a lot of times you want to go even more granular and you want to collect the data only from one particular container in a pod, because rest of those containers may be just some sidecars. So you have a specific container, you can also use a container specific resource, and this gives you access to CPU, memory, all this, default resources. This is the resources we're talking about. So get pods would top pods rather shows you CPU and memory, right? Those are the resources you can scale based on. You already have access to this data. You can also use an external metric. So this allows you to add any custom source as for the policy, basically. You can also have, resource metrics. So there's some variations of these. I've not experimented with everything. I've looked at pods, which is the previous one. Container resource is what I'm going to use because I want to go very granular. And based on this, how do you want to scale out? How do you want to scale down? That you can define with the behavior. Now, this was not possible earlier to change this behavior, uh, define how many pods you want to scale with, like launch 2 pods, launch 3 pods, launch 10%, 20%. So you can define all of that now. And that's what I have here for you as part of this configuration. I'll explain this and then I'll create this and show you by running a actual load test. So if you look at my previous code, it was version 1 was very simple. Okay, I've already replaced it with V2. So earlier was very simple, and this one is much more sophisticated. So what all do we have here? Let's look at it. So I'm creating a horizontal pod autoscaler to define that policy. Let's look at the spec now. What is the minimum? Minimum is 2, maximum is 10. So my range is defined, the boundaries at both ends. So minimum, I want 2, maximum it can scale to is 10. You can change that values based on your numbers and so on. This is a good place to start with, I thought. And this does work on this cluster as well. If you go too high in the max replicas, it might bring down your cluster again because of the reason I mentioned earlier. Based on what? I am defining metrics, container resource. What resource specifically? CPU. For which container? App container. So I'm going to do this for what application, but what application has this app container? You can see that here. So if I describe, let's find out what container does it have. The name of the container is called as app. So whatever you have as part of your spec, you basically work with that. So if you look at vote-rs, the name of the container is this, name of the container is this app, and that's what I'm referencing. So I'm saying that check for the CPU utilization, average CPU utilization across all the pods and app containers across it. And if it crosses 50%, start scaling. So scaling out, scaling in will be based on this average CPU utilization number being 50%. And then what are we scaling? A replica set whose name is 4. That's the target. Behavior is where I have scale down and scale up policy. Let's just look at one so that you'll understand the second also. It's simple. So there are two policies I've defined. So there are two different policy types actually. Let's say when the CPU utilization goes above 50%, for how long? Let's say scale up policy. Let's look at that first. For how long? I want to scale up very fast. So I'm saying watch for last 15 seconds. And if it crosses 50%, start scaling out, launching new pods. How? The type is pods. So either launch 2 pods or launch 100% capacity. And out of this, select policy is max, as in whatever is the largest, whichever is the highest number, pick that. In this case, we have 4 pods running, so it will not pick this. It will launch 4, and it will keep on launching that many. 100% is whatever is currently. So it will keep on doubling that number every 15 seconds with this policy, basically. So I'm saying percentage 100. So, and then I'll say you don't have to worry about stabilizing it and so on. Sometimes what happens is you may want to give it some cool off time. So you have scaled down and you don't want to do it again, or scale up. You want to wait for a few seconds for it to come up, serve, actually start working. So you can define that as a stabilization window if you want, right? So within that window, let's say if you define a window of 300 seconds, within that window, once the event has happened, once it has scaled down in this case, it will not scale down for the 5 minutes window, right? That's when you want to stabilize it and so on. You can define that as well. So in this case, the scaling down policy is similar, scale down by 2, but scaling down, I want to take it easy. I'll wait for 2 minutes data, and only then, only if it is lower than 50% for 2 minutes or more, I want to scale down. And by default, the select policy is max anyway. So whichever is the maximum, 25% or 2, it will scale down those many pods. So if I'm running 10 pods, it's going to pick 4. If I'm running 4 pods, it's going to pick 2, whichever is the maximum. So it's basically that. So scale up, scale down. You can define all of this. You can leave some of this behavior as is, and it will just do its own default thing. You can also rely on default behavior, but I just wanted to show you what all you can do with version 2, and that's what we have. I think almost everything is there as far as the default resource policies are concerned. So let me create this auto scaling configuration. And let's find out what happens here. HPA is created. We'll watch for, if I had Grafana or something, I would have seen some data like this also. Since I don't, I will not bother. I'll just watch for this. I'm going to put this on a watch on a dedicated window. And what am I watching for here? Okay, let me show you. So I see the horizontal pod auto scaling configuration. It's for replica set board. It is already monitoring. The target is 50%, current is 2%. So it's not going to scale anytime soon with this current state of affairs. Minimum is 2, max is 10, current replicas is 4. If I just leave it at this, after a few minutes, after 2, 3, 4, 5 minutes, it will scale down to 2 basically. That's what it's going to do. It doesn't. So now the number of replicas that I have in replica set is just a kind of a desired, or this is what we start with. But then uh, the range and the scaling activity and the number of replicas management is taken care by the autoscaler from now onwards. That's what is going to define how many will be there at any given point of time based on the current state of affairs, which you see here. These are the 4 pods running. This is the replica set. And then it shows me what's going on. Uh, Number of replicas, the behavior, the configuration, basically. What is the current configuration? What has happened recently? Why? Right? So it says desired count is within the acceptable range. So everything is fine. That's what it says. Now let me create some trouble. I have this CPU utilization based policy. So I'll add some load test. And to run the load test, I'll put a load balancer on top of that also. So I'm already here. So this load balancer or the service, will talk about it next week in details. So don't worry about it at all right now. Think of it as it's just launching a load balancer. And I'm launching a load test job by creating a configuration like this. Okay, where I run an application called as Siege. So there are various ways of doing this. So I'm gonna run a Siege. Benchmark is just bombarding this with thousands of connections, and it's gonna run for about 6 minutes. I'll create this as a job. A job, the difference between a pod and a job, it runs as a pod, but the job is run one off. So after 6 minutes, it will just mark it as completed. And it started this load test, which I can watch for using the output of this also. It has started it. It's saying preparing for siege and all that. And yeah, so concurrent users for battle. So I tried with more users and it just, bombards it with too much of traffic. You already see it's gone up to 40%. And within a few seconds, it's going to reach the threshold by a very large margin, 346%, really taken up too much. And that's the reason why it should start scaling out. Number of replicas is still 4. You're going to see that change very soon. Yeah, new sizes. It's already gone to 8 and 10 because in 15 seconds interval, it is making that decision. I think I should increase that interval, but it's happening very fast. But within 15 seconds of interval, you can see that there's a 15-second gap between this and this. Right, and then it basically says CPU resource utilization is above target, and based on how much it was above, it just launched 10 replicas altogether. It started with doubled it first, so from 4 it went to 8. From 8, if I had not defined it, it would have gone to 16 in the next 15 seconds, and from there it would have gone to 32 because that's the step we are scaling it up with right now. And that's what is going to happen here. If I kill this load test, it's already kind of exhausting the connection. I'm going to kill this load test by deleting that pod. All right, and it should bring it down again. And then while scaling down, you're going to see it will scale down slow. That'll be a slow and steady. Because while scaling down, it's going to wait for 2 minutes. Look at the 2 minutes interval, give it a cool off period of 300 seconds. So 5 minutes. Only after that, the next event will happen. So I believe 25% will be 3 to 4, it is going to bring down. And then it's going to bring down a few more later. Will take some time. So it's gone below the target already. You can see the top kubectl, top nodes, and pods as well. You can see some memory spiked up, CPU definitely on all these nodes. And here now it is back to normal. It's almost none, right? So right now it's showing the current, not the historical data. So this is the current data, and you can see it is scaled out. It's gonna scale down or scale in. That's what a autoscaler, namely horizontal pod autoscaler here, is doing basically. And it's doing a pretty decent job. I'm quite happy with the changes which have been brought in with V2, because earlier this was not possible to define what scale, what step, what is the percentage or number of pods. You can also bring in a lot more metric information. Now you can go up to the container specific load, kind of a information as well in terms of resource utilization. So that kind of monitoring, and based on that you can make the decisions. So all of that is possible now, which is a fantastic thing to have. So all of these are recent changes to Autoscaler. Pradeep has a question during scale down. Is there any particular strategy to kill what pods, or it's just random? Uh, in my opinion, I believe it is when it scales down, it kills the latest pods first. So the oldest pod trim are the last one to go. That I believe is the default way the replica sets work also. Can that be changed? I will have to figure out also. So it's not there in replica set, but have they introduced anything in here with the scale down and so on? I'm yet to explore all of these things, right? But as far as I know, that's what happens. The most latest ones are the first ones to go. All right. Okay, I think we have addressed most of the relevant question to this session. And we're just waiting for the scale down to happen. In the meanwhile, if you have any questions, I would be glad to address those.
Gaurav, Pradeep, a quick question.
Mhm.
On the metrics, like when you measure that CPU utilization, like you're measuring against the node CPU utilization, or it's just a pod in general? How does it measure?
CPU
So,
utilization, when we talk about autoscaler, from the context of autoscaling policy you're talking about, right?
yeah.
Good news is it's not even at the pod level, it's at the container level. And it is doing
Oh,
that because you can see that what we have added, and this is a recent change, by the way. Earlier it was based on only pod specific things, so collective CPU utilization across all the containers in that pod is what we are talking about there. But now let's imagine you have 3 containers in a pod, 2 are sidecars. You don't care about their data resource utilization specifically, but you care about your main applications resource utilization, CPU utilization. You can do that with this property called as container resource. So it's container specific, and you can specify which container in this app, right? We are talking about, and based on that, it is making that decision actually. You can see that here in the spec as well. So if you look at horizontal pod autoscaler, we are talking about the spec for that. And metrics is where this is a new thing, right? So earlier it was based on the pods only. So this is, each pod. Now we say resource metrics, single container in each pod of the scale target is a replica set board. So it is we are referencing that. And one container also, you can go at that granular level and set up a policy based on that. And then you can add additional policies, which are external policies and whatnot also. But what we have here is specific to a container, not even pod.
So let's say like you don't have any resource limits explicitly mentioned when you're creating a pod or like whatever. So
Okay.
that is what happens.
Limits are basically, limits is a different thing than the scaling. So CPU utilization will just look at the monitoring data of how much of CPU it is consuming and whatnot. And then limits will be for setting up the hard limit for that CPU. So are you talking about when we say average utilization, it is 50% of what is what you're talking about?
Yeah, that's exactly. In what context? It is comparing with your whole node CPU or like it is comparing with what is allocated to your pod?
It can't be a
Uh,
node. It is not node. It should be one of the uh, request or limits. It would be one of that.
yeah, that's exactly. Yeah.
So
Okay.
which one is it? Let's find out. I have to confirm that. It might be okay. So this is
Because
average.
I'm kind of comparing with the AWS auto scaling because that auto
Correct.
scaling works at the node level, VM level.
Because AWS Autoscaler, EC2 Autoscaler is scaling just the nodes or the VMs. So it looks at that data. Here we're comparing, scaling the pods and containers. So we have to look at container specific. It won't be node specific for sure. It is one of that, either limits or resources, request or limits basically. And that is what we are talking about here. So which exactly how it behaves, I will try to discover and will
Yeah,
probably take it up during our Thursday session.
yeah, okay, no problem. Yeah.
Yeah. Okay. Cool. All right, Abhishek has a question. What if there is an important data that is provided by the user during the scale up and there was no load coming for the mentioned threshold and pod starts getting deleted due to scale down? What happens to the data? Will it be lost? Yes. So if you are, if you're keeping the data on the pods and when the pods get deleted, basically, it is just going to give it some maybe a grace period, maybe a few seconds, that's it. But otherwise, it will just get deleted. It's not going to worry about what data and how and all that. So for this, you'll have to have some mechanism to, if it is a stateful application, or if you want to keep some data, you store it in a queue, or you put it in basically in a database or somewhere else where the pod is connecting to. So you don't store anything anyways. The pods, you don't store anything there. You have to store it in a database volume somewhere so that you don't lose the data. And if it is a work in progress, you'll have to work with retries, like client retries, so that if the pod connection is gone, it goes to the new one. And some sort of queue workflow management where you take the data from somewhere. But if it is not responding, that data is not removed from that place, right? And then next pod comes in and processes it and so on. So you'll have to rely on some of that kind of a mechanism for this to work. All right. There's a question from Navraj about, is storage constraint a valid metric to scale up? Depends on what you are scaling up. And when you say storage, if it is, let's say, sharded Redis, which is sharded, and you're running out of disk space and storage capacity and all that, and you need more capacity, and increasing the number of instances would give you that. In that case, it would make sense. But a typical application where you have more like a web front end and so on, there it may not be the right constraint or a right metric to scale based on. So most likely you're gonna scale based on number of requests coming in, average number of requests, latency. So, those kind of metrics are more appropriate for those kind of application. But as I mentioned, if it is a storage cluster, for example, and adding more nodes solves the problem, in that case, it could be based on storage as well. There is no limit to what you can do because you can feed in custom data here anyways. You can see the scaling down has happened already, scaling in has happened already. And based on what you can see that here, it went from 8 to 10, then it came back to 7, then it scaled down to 5. Now it is doing it based on that max is that number of instances, right? So scale down. So it's using that policy now. And every, let's say if you look at this interval, it's almost like 2 minutes interval. So almost every 2 minutes it's scaling down. And that's what is happening. And it's probably going to hit that minimum at some point of time, which is 2. And then it will stop scaling down beyond that because that's the minimum it has to maintain anyways. But what you see is the scaling, auto scaling in action already with the conjunction of the replica sets here. All right, and that's about it. So that's all we wanted to talk about this week. I have shared the lab guides with you already for both of these. For namespaces and replicas, there is one lab guide, and you can just go to this Kubernetes tutorial and you'll find it here anyways. So this is something you can just bookmark and use. The lab for replica sets is this K104, and the one for the auto scaling is 301. Okay. This has been updated, so you should see everything working as I demonstrated to you. And beyond this, if you are not a member, especially the folks on the YouTube stream, you should definitely consider being a Geek member because you'll have access to the courses. We have detailed courses, whatever I'm explaining here. I have an in-depth course explaining each of this topic with the labs and projects. We have a bunch of projects, so we are going at a rate of like about 4 projects every week for every mission. So we'll end up having 30 plus projects or so, and that would help you definitely build all your skills and prepare for the exams much better. Along with that, we are trying to make the group projects work. And if that works, that's going to be even better. We're creating group of 3 this time, triads we call it, and we're working as that. And we have a very nice discussion last week we talked about certain problems, challenges, and all that during our members only call as well. And you have access to that coaching plus the certification and the badges, which is part of our gamification. So if you're not a member, definitely consider that. That would help us do more things as well, and bring more interesting, useful content to you if you see the value in this. All right, so that's about it. And we talked about scaling during this session. Talked about namespaces, context switching, very useful from this exam point of view. ReplicaSet is a foundation for deployment anyways. So this is one of the foundational topics. It also maps to certain topics as I just mentioned to you. So context switching is important. Scaling application is one of the exam topics of CKA. Understanding primitives to use, create robust self-healing application deployment. Again, it's part of this. How to monitor applications, metric server is one of that. And how to, again, monitor the applications. One of that is using metric server. And then there is can be more things beyond it, but this is the official way of you start monitoring the pods and stuff and then scale it based on that and so on. So from that point of view, this is very important. Next week, we'll take up networked ICE. That's when we'll talk about service networking, a very important topic. You shouldn't miss that. Very useful, important topic. So we'll talk about load balancing, service discovery, how service networking works under the hood, CNI, a bit of a load balancing, and all of that interesting stuff that we will take up at that time. So do not miss the next week's session. And with this, unless there are any questions, so how to track, the question from Dinesh from stream is how to track when and why the scale out and scaling happened. So it's very easy. You can see that here, you can see why, when the scale out happened and why. you already see that size and why it happened is below the target, meaning there is metrics basically are going down below the target and so on. So you do see some information and in the logs and the events here. And you can find out possibly more information from the monitoring. If you do monitoring in a more sophisticated way, you can correlate that with the whatever those policies that you have with the monitoring data as well. But you do see at least certain events where whenever there is an event happens, scaling out or scaling in, you do see some events already here. And maybe you can change the debug level for the log level as well to show you more information than this too. That's how you can keep track of it. All right, so Pradeep talks about, can I share this document? Yes, sure. So mission 3 document or whatever this curriculum document, let me share this with you. Those of you are completely new also on the stream, this could be useful. So
yeah, I'm not sure whether I can access this doc via portal because I'm already a nerd membership.
Sure, I had sent it as an email, but
Okay.
let's me. When we started with this Kubernetes dojo, we had shared that, but let me share it anyways.
Okay, no problem.
Just give me one quick moment.
The reason I'm asking, I like the way you map it to the exam because I'm preparing for the test. So I just want to make sure.
Yeah. If you're preparing for the exam, you must have this because you will exactly know what are the
No,
topics we are
yeah,
covering. Are we omitting any? You'll also know that. I think
yeah,
it's all of that is covered, but you can figure it out based on this.
that's great.
That's
Great
the
insight.
whole reason I created this, actually. That's the purpose for this. Here it is, curriculum. And on the stream goes right there. All right, perfect. So thank you very much, everyone. We'll close the session here. And I'll see you next week with the next mission and some interesting topics related to service networking. And possibly, if it is possible, I'll try to compress it along with Ingress as well. Let's see how that goes, though. Right? But service networking, definitely. And it's a very important topic. Don't miss it. Thank you, and see you next week. Bye-bye.
Thank you very much.